All right, let's go with this one here. All right, what's this? This is June 2023, right? All right, let's go with this. Right, two significant figures. That'll be just be 3.1. So that'll be Apple, right? Give an example of a vector quantity. Right, I might go a little faster here because I want to go back and do our next advanced paper, right? Because there's one with a tricky question. Next one, an example of a vector quantity. The only vector quantity here is displacement. Right, next one, which are the following instruments for diameter over here? Well, we can't use the top three, we're using the micrometer screw gauge. All this is a pizza. I didn't like this year too much. Had a year that was nice. So it's Jan 20. It would have been last year. So that'll be Jan 2023 or 2022. Nice year. What would be the magnitude and direction of the third force to make it stationary? Well, we have to have a force. That's X plus Y acting to the left. Right? That's boy. Number 5. Which of the following is a derived unit? One, we know meter cube, that's derived. All the others are basic, right? Right, a block is allowed to fall freely towards the ground. As it falls, its gravitational potential energy. As it falls, kinetic will increase, potential will drop, right? So, which one here is the best answer? The gravitational increase, constant, no, is converted to kinetic. Right, that's dog. You're not incorrect.
Shut up.
What is the... What look all here have, boy? I tell you to clean up this thing. What is the reading shown on the thermometer? Right, here's 80. So all you have to do is figure out what each one is. It's like 2, 4, 6, 8. Right? So that's 88. Just to put up.
Huh?
Yeah. Right, so that's around 88, right? Which of the following is the unit of momentum, right? kgms minus 1, right? Mass by velocity. Right, that's number 8, right? Number 9, kinetic energy, nice and easy. That's D. When is ADMAS, sorry?
Monday.
All right. All right, keep practicing, and if you're I here until when? Tuesday, right? So look at just practice, send the hard ones and I'll do it, right? Just in case I don't get much more time, because I'll keep after this. Right, a body, what year is this one? This is June 2023. A body initially moving at a constant speed is brought to rest. Which are the following indicates that a body moving at a constant speed and is brought to rest at a uniform rate. That'll be C. All right, C is the answer there. Next one, Helgade. Sorry, a 4 kilogram mass is traveling at a constant speed is brought to rest by this, right? So we know that F is equal to M by A. So the mass is 4. The final velocity is 0. Initial is 5 all over 2. So I got minus 10, right? So the average force is 10. Minus just means that it's opposing force, right? Right, an ice cube sinks, what all this reading now? An ice cube sinks in liquid A. So it sinks in liquid A, right? But it floats in liquid B, right? But it floats in liquid B. And it floats in liquid B. So let's see which one is true. So obviously in this one, the weight is bigger than the upthrust. In this one here, the weight is equal to the upthrust. And remember, upthrust is the weight of fluid displaced, right? So the upthrust is less in liquid A. This is A, and this is B. The upthrust is less in liquid A than in liquid B. Upthrust is greater, is less in liquid A than liquid B. The weight of the ice cube is less. Well, the weight of the ice cube wouldn't change, right? Right, so which upthrust is bigger? Obviously, the upthrust in B, right? Right, so we got apple is less in A than in B. You have to be careful with the wording, right? 13, a bus with luggage. A bus with luggage loaded on top is more likely to topple over when rounding a corner than the bus without luggage, right? Because you increase the center of gravity, right? Raises the center of gravity because the luggage raises the center of gravity. Okay, so it's less stable, right? Remember stability. Next one here, right? Next one here is which of the following is true about the spring above? Is elastic limit is exceeded here. It obeys Hooke's law, no. The force per unit extension, is it this, or we better work it out, right? Remember, F is K on E, K is equal to F over E. So we could use these values here. We could find gradient, which will be 1 on K. So that will be 10 over 75. Flip it over again, yeah? So 1 and 3 looking right, boy. 1 and 3. Next one, power. Not work done. Not that. Rate of change of energy. Rate of change of momentum. Best answer, cut. Right, next one. Two forces, 8 and 10, cannot give a resultant. Start with the largest. That's the largest. Smallest is 2. So you get 2, 8, 18. You can't get 1. Right? 1 impossible. Right. Sorry, they are trying to eat too. X, Y, and Z are 3 billiard balls of equal mass whose centers lie in a straight line. Y and Z are touching X travels the velocity of 20, impinges on Y. I mean, just collides with Y, right? Assuming that these pairs are perfectly elastic, the resultant motion after impact, well, we know this from Newton's cradle, right? Z should move off with the same speed, right? X and Y remain constant. X and Y stationary, YZ moves off with the velocity. The only answer close to that is B. Okay? That's like Newton's cradle. What's the gain in gravitational potential energy? You have your weight and you have your from a height to, that's just 5, right? So you can just climb height. So that mgh, your change in height is just 5 meters. So your gain in potential is 200 by 5. Mg is your weight. So C is equal to 1000. Which of the following remains unchanged with an increase in temperature? Right, you can't really change the mass, right? You can change the volume, which will change this and this. You can't really change the mass. 20. Which one sounds like number 20 here? What y'all think? Any answers? Specific heat capacity. It will raise the temperature of unit mass by 1 Kelvin, right? So that's dog. Good job, Keshav, right? That's dog. Next one. They give you the length of vaporization, they give you the mass, they want to convert water to steam. So E is equal to MLV, right? Remember, MC delta theta for temperature change, MLV or ML for phase change, right? So this will be 0.01 by 2.26 by 10 to the 6. So that minus 2, 6 minus 2 by 4, right? We have water going to steam, so energy will be lost, right? So energy is absorbed for the break out the bonds, right? So that energy, 2.26 absorbed, okay? 2.26 absorbed. Remember, when you're doing questions like this, right? Make sure your temperature is in Kelvin, right? So you have P1, you have T1, and you have P1. So everything changing, so we're using general gas law. Right, so that's 2 by 300 all over 1, 2 by V2 all over. Wait, did I write it in the right place? P1 is 1, sorry. All right, I'm in the wrong place. Hold on. P1 is 1. V1 is 2. Yes, 300. All right, P2 is 2. V2 is what we're trying to find. And the new volume is, oh, sorry. Volume is 1. I'll just write everything in the wrong place. Right? So no maths required. You'll recognize that this and this will be the same thing, right? Cross multiply, work it out. you will see T2 is 300 Kelvin, which is 27 degrees. That's okay? The following methods is best suitable means of heating a brass bulb. In order to determine the specific heat capacity by method of mixed cells, subjecting it to open flame, subjecting it to infrared beam, boiling it in a water bath. That's always the best thing to do, right? Put it in a water bath for 10 minutes so it can evenly be heated. So 23 is C. 24, according to kinetic theory, when a glass is in a closed container, it's heated, the pressure rises because the molecules move faster and hit the walls of the container harder and more often, right? Always remember that collisions increase, right? Right, yeah, just checking out B2, B has something similar, right? But pressure is really as a result of collisions with the walls, with themselves too, but more with the walls of the container. Next one, you know this one is a standard one, right? The looking for where it tapers off at 18 or plateaus off at 18. That's C. Right, that's a cooling curve. In which of the following is conduction the main method of transfer? Food heated in a microwave, now that's convection as well. It's radiation because it's electromagnetic radiation they're using. Energy transferred from the sun, food being cooked on a barbecue, food being cooked on a pot on an electric stove. Right, so we'll go with D. Right, the main transfer is conduction. Remember, from the coals to the meat will be convection, right? So we'll have to go with dog here. Are you okay with that one? How about this one? What do you get for this one? Right? Which of the following are reasons why a hot liquid placed in a double-walled vacuum flask retains its heat for long? The silvered inner walls, right, reduces heat loss, yeah, correct. The silvered outer walls helps to absorb heat now. The evacuated space reduces heat loss by, yeah, part 1 and 3. Right, that's boy. 1 and 3 is boy, right? So 27 is boy. 1 and 3 sounding good. So a person coming out of the sea would feel cool because the seawater is cool. No heat is lost by radiation. Not yet. The seawater evaporates from the skin, keeping it cool, yeah. Right, so we could probably go with C. Right? So the seawater evaporated from the skin, cooling it down, right? So you'll feel a little bit cooler as it coming out. 29, kinetic theory of matter suggests that molecules of a gas closely packed, far apart and vibrating from a fixed point, moving at random, dog, right? Item 30 shows top boiling, water boiling at the top of a glass tube while a piece of ice remains unmelted at the bottom, right? So it's not melted, which are the following. Water is a poor conductor, but the water boiling, right? The water boiling, right? So it means that most of it at the right temperature. So we'll go with the gauze being which is metal gauze. This one here, I have different answers to this one, You see, one of the things is that because the water boiling, everything should be at the same temperature. So water being a poor conductor is not really a reason. But what they're trying to show you here is that here hotter than here now. So the reason for that. Gauze is a very good reflector of heat. Right, it's metal gauze. This one different. One of the years is not metal gauze. But it should be a good conductor of heat. Okay, I had to check over this one, but I had to go with based on what it say. Because of metal gauze, it should be a good conductor of heat. So it can't be this, it can't be this. Right? Well, definitely not this. I might have to go with A for now. It's not normally metal. Anybody came across this one? So we had to go with A for this one, right? Water being a poor conductor. Right? They just trying to highlight that the difference in space they're showing that one part hot and one part not as hot. So water is a poor conductor. The next one, the gauze wasn't metallic. This one here. Okay. Yeah, so we'll go with A. Item 31 refers to the following diagram: profile of a wave. They gave you, remember, you can't get right. You gotta pay attention to this one, right? You want frequency. This graph doesn't read off time, it gives displacement against position. So you can't read off time from this graph. You can read off the wavelength. The wavelength is 20 centimeters, right? But you can't read off anything else, right? And they didn't give us speed. So we can't find wavelength. So this one is unknown, right? This one is unknown, which is dog. The sharp edges of shadows suggest that light travels in straight lines, right? So it can go around and give it that blurriness. Either it passes through or it doesn't pass through because it's going in straight lines. 33, an echo is quieter than the original sound that produced it. This shows that the echo is right. Remember, if it's loudness has to do with amplitude. So if it's softer, it means that the amplitude dropped. Okay, so it means it has a smaller amplitude. So 33, boy. Right, 33 is boy. 34 refers to the following diagram, which shows two similar loudspeakers connected to the same audio frequency generator. Right, it's separated by 0.5. At some points along XY, no sound is heard, right? Because the waves diffracted, no interference of sound waves take place, right? That's destructive interference. Okay, so that will be boy as 34. 34 is boy. 35, a ray of light leaving air enters a glass of refractive index 1.6. The angle of refraction, find sine of the angle of incidence. So we know the formula. So you want to get sine I, that will be the refractive index by sine R. So that's 1.6 by sine 27, right? That's dog. 36, which of the following wave travels only longitudinally? Sound waves. These two could travel transverse, right? So one alone, sound waves. Which of the following can produce a diminished virtual image, which means smaller, right? Right? Convergent, no divergent. It can produce a virtual image that is diminished, that's smaller. If it's convergent, it can produce virtual that's enlarged. So this one is boy. Total internal reflection in glass occurs when the critical angle is exceeded. A ray of light in air strikes a glass block. A ray of light in air strikes a glass block at an angle of incidence of 0 degrees. On entering the block, it will be undeviated, right? It means it's traveling along the normal. So something like this, right? If you have a normal here, it means the ray traveling along the normal. Once it goes along the normal, it's undeviated. That's 39, 40. The position of an image formed by a plane mirror depends on the distance of the observer from the mirror. So the position of an image is really dependent on the distance of the object. Right, so that's boy. Which of the following is magnification? One correct. Only one correct, right? It must be image over object. So the answer is apple. Right? Some of these are new ones, huh? Apple. .42, the value of I at time t1 is called the peak value, right? That's a peak value. That's your largest value. Okay? Your root mean square is like if they give you an average of a AC. Right? 42 is a peak value. Right? When polythene rod is rubbed with cloth, it becomes, right, so some things you could totally ignore here. It could never gain protons, right? Negatively charged by gaining electrons, positively charged by, that can't happen. Negatively charged by losing protons. None of them make sense, right? None of them make sense except for boy, okay? Remember, the protons can't move, right? Just the electrons. Which of the following shows the magnetic field? Well, it's attraction, right? Magnetic field lines never leave the south, right? So that's wrong. They always go towards the south. So the answer is cut. Right, the answer is cut there. Item 45 refers to the following circuit where the ammeter reads 0.4 and the voltmeter reads 0.6. What is the resistance R? Right? What do we do here? We know the voltmeter reading and we know the current. Oh, we just have to define. That's all. The voltmeter reading is 0.6 and the ammeter reading, which would be the same current, both of them is 0.4. So they want the resistance 0.6 over 0.4. That will cancel, so you'll get 6 on 4, which is 3 on 2, which is 1.5. Right? Which is 1.5, 46. A conductor rotating in a uniform magnetic field induces maximum instantaneous current when it's at 90, right? That's Fleming's right-hand rule. Must be 90 degrees. Which are the following relationships between RT, R1, R2, R3 conducting parallel? Cut. Right? This will work here. Did this one work, right? This is only work for 2 resistors. A voltmeter has a very high resistance so that it can be placed in parallel and not affect the circuit. Beautiful. Right? You don't want it to pull. You don't want it to pull anything, any current from the circuit, right? So you connect it in parallel. All right, which of the following graphs is alternating? A is direct, B direct, C kind of weirdish. So we'll go D, right? Right, alternating means a change in sign. Alternating means a difference in fields. All right, plus minus, plus minus. Which of the following arrangement is best suited to measure the voltage? Well, it must be in parallel across the lamp. Yeah. Not the resistor. The resistor, this will mess up the voltage reading, right? You wouldn't get the true voltage of this. So it has to be across the lamp alone, which is C. Which of the following represents series? When you're looking like B looking like series, boy. Right? Boy looking like series. This one here, a little circuit diagram. What is the output at C and D when the input 0, 0 is made? Right? So you want 0, 0, so this will be 0, and this will be 0. Well, like 0, 0. Apple. Right? 53. Using the diagram, using the information given in the circuit diagram, which pairs of values I1 and I2 is correct? Right? So remember, this is a smaller resistance, right? This is a bigger resistance. So what will happen here is that more current will flow here as opposed to here. And it might actually split up in this ratio. 4 amperes on top, 2 amperes below. 4, 2, right? So basically, you just have to make sure that the current in I1 is more, and that's dog, right? 53 here is dog. 54, which are the following? Is there a problem to get multiple choice or like 20, like all the years? I know it have all those sites. I never, to be honest, I don't really pay attention to multiple choice because I know it have answers and it have all the papers. But is it a problem to get solutions and answers? Sorry, solutions and papers? No? You again? Okay. Which of the following materials is most suitable for the core soft iron, right? That's D. 54 is D. Right, that's this one here. Soft iron core is the best for electromagnet. According to Rutherford and Bohr model of a neutral stable atom, according to the Rutherford model of a neutral stable atom, protons equal to electrons. Okay, as if it's stable. Which of the following symbols would be isotope? Same atomic number, different mass number, right? So Z has to be the same. That's only one is dog. Only one there is dog. Which of the following cannot be deflected by a magnetic field? You should know this, gamma. Right, that's gamma. Which of the following statement is true for both iron and steel? Right, iron easily magnetized. Steel retains its magnetism well. I think this one is B. Anybody ever come across this one? I can't remember this one, to be honest. Right, you're checking that one to my right. I'm not too sure about B. About 58. I can't remember iron or steel. Right, who discovered radium, mercury? Anybody have that one? Bradley? 58. Which of the following equations is correct? Which of the following is correct? Which one is that, Keshav? 58 or 60? This one here, yeah, 60 correct, yeah. Remember alpha is 4, 2, right? So 4, 2. Right? 4, 2, that's the only one that balances up, that's C. Okay? 458. Remember this. Well, I asked ChatGPT for now. I know this one. Let's see if I could find it. $58 is B. Okay, all right. Yeah, I can't remember. I think they use iron and steel as an alloy to make the soft iron cores because it easily magnetizes and retain the magnetism. All right, nice, good. Anybody have 24? We can squeeze in a little more with the physics. Anybody have? I had Jan 24. I don't know who I share that. Anybody have 2024? Or any hard questions? All right, we still have some time. Let's take a look at I have an old one here. That's 2021. Right. What is normally be hard? Let me see. Can't hear them. There's repeats. Well, to me, it's repeats. Huh? So if I just see any hard ones there. See how much of them is repeats already. I'm reading the one here. Look at here. Right. This is the one wrapped in gauze. Remember, gauze don't have to be metallic. Huh? So this was one way you could have said that the gauze was a poor conductor. Right, but I think they changed it to the one that we saw recently. So it'll all be that. Here's a new one with reflection. The angles have to be equal. Right? So that is Apple. Right, look on here. Right, if they give you, if the first to the following diagram, they give you longitudinal wave, they give you compressions and refractions, right? If lambda is wavelength, then the distance C1 all the way to R2 is what? Right? C1 to C2 is a wavelength. So this is one wavelength. So there's a half a wavelength. So that's 1 plus a half wavelengths. Okay? That's 35. Oh, wait, no, don't worry about that. This one here. Which of the following best demonstrates a wave generated in a ripple tank by a small dipper, right? Vibrating at constant frequency. So the period should be the same. The only thing close to it is Apple, right? The only thing close to it is Apple. X-rays, position, I'm gonna do that one already. Well, IV graph for a metallic conductor, you know that one is D, right? All right, we do this one already. That's just a formula. Right? Remember this one, the only thing I keep them apart is the electrostatic force, right? Is a EC and DC, right? It's the same concept. The only the DC here is E. 47 is A. This one's a transformer, right? If you look closely, it's always an AC input, right? So don't worry what it is. Right? You have 2 coils, let me say 3 coils here, and you have 1, 2, 3, 4 coils here. So you're stepping up. Right? You're going from smaller to less. So it's a step-up transformer. Right? Rectification is done by a diode, right? Here, what do we have here? Those are slip rings. You see in the whole ring, that's a slip ring. If you only see half the ring, well, that's a split ring, right? I mean, a split ring, if you see half of the ring. Right? And it's a generator. AC generators, they use slip rings. Right? Do that already. You should know your gates, right? This is an AND gate is boy here. The AND gate is boy. Right? What's the particle missing here? What's the particle missing for this one? The mass number increased by 1, the atomic number stays the same. Right? So this wrong and this wrong. So the answer is boy. Right? Oh, like a half-life. I did the last one here. Right? A radioactive isotope has a half-life of 20 days. Right? So they give it the half-life is 20 days. how many days will it take for a given sample to reach 1/8? 1/8 takes 3 half-lives, right? Remember, you use the formula 1 and 2 to the n. 3 half-lives, so that's 3 by 20. That's 60 days. Boy. Right? Easy stuff. The more years you do, you will see how much piece it will have, right? All right, nice. Take a little break, and then we do a maths, right? I think I have a recent maths too. All right, take a little break, and then we'll do a maths. If we can do 2, that'll be good.